Now, what we have to think about, though, is we don't always solve systems by graphing. So when we're doing substitution or elimination, what does it look like then? All right, well, let's take a look at two examples. All right, so here's one system I've got, y equals negative 5x minus 2, and 5x plus y equals 0. Now, I've already graphed it. If I were to graph it, I get this graph. Two lines running parallel with the same slope. So because they're parallel, they never touch. And so like we were just discussing, that means this system would have no solution. All right. So we know what to expect. We know that if I solve this, there isn't going to be a solution. But what does it look like when I'm not graphing it? So if I put the graph to the side, we do this problem. Let's solve it together. Now, based on what we've discussed, I think a substitution would be the best bet here. We'll make this our substitution equation. And everywhere I see y, I'm going to swap it out and substitute in negative 5x minus 2. All right, so I'm going to do that to this equation. 5x plus blank, swap out y, equals 0. And in place of y, we're going to substitute in negative 5x minus 2. All right, now in this case, the parentheses don't really serve a purpose. They're just a placeholder, so let's clean up the like terms. 5x plus negative 5x is 0x, which just vanishes. And so what I get is this. Negative 2 equals 0. Okay, now this hopefully should look familiar. This is something we did in chapter 1 where we were solving for a particular variable, in this case x, but the variable disappears, and not only that it disappears, but this doesn't make sense. Okay, so this means that this problem has no solution. This is in fact something we've seen before, it's just we weren't working with systems at the time. We were working with just straight equations. All right, so anytime you're working with systems, I don't care if it's substitution or elimination, if your variable vanishes and what's left over doesn't even make mathematical sense, it means that it must have been this situation. Two parallel lines that never touch, and so the system has no solution.